In the previous lesson, we looked at exponential relations. So we saw that when you graph an exponential relation, it has a curve that doesn't look like a parabola, and it's not a line. And when you look at the table of values, the first and second differences are not constant, but the ratios between the y values are. In this lesson, we're going to look at graphing exponential relations. So just like we can graph lines and graph quadratic relations, parabolas, using an equation, we can do the same thing with an exponential relation. We're going to have our equations in this format. Y equals a times b to the exponent x. So x and y are just the variables that you plot on your x and y axes. A and b are numbers in your equation. And the values of a and b tell you something about the graph. So that's what the focus of this lesson is on. I want to start by looking at this value in the equation, the b value. That's the base of the power. If the base is greater than 1, your graph will have this sort of a shape. If your value for b is less than 1, then your graph will have this sort of a shape. Now this shape here, this is called exponential growth. And this shape here, this is called exponential decay. So you have to be able to determine whether or not your relation is exponential growth or exponential decay. And you can tell from the equation by looking at the value of b. If it's less than 1, it's decay. If it's more than 1, it's growth. Now the value of a, the very first number in your equation, this is the y-intercept. So whatever a is, that's the y-intercept. That's where it crosses the y-axis. B, we already looked at it. It tells you whether we have growth or decay. So this is called the growth factor or the decay factor. You might also hear growth rate or decay rate. It means the same thing. Now, if we look at exponential relations like these, there are no x-intercepts. The curve will never reach the x-axis. It will get closer and closer and closer, but it will never touch it, and it will never cross the x-axis. So there are none. There are no x-intercepts. Keep these things in mind as we go through some examples. So here we have 3 different equations. They're all examples of exponential growth because the b value in each is greater than 1. So let's look at the first one. B is 2, so that's our growth factor. What's a? We don't see a number in front. That means it's a 1. So a is 1 and b is 2. A is 1, so we'll plot that point. Now b is 2. That's the growth rate, the growth factor. So what does that mean? Well, that means every time we go over 1 unit on the x-axis, we're multiplying our previous y value by 2. So here, my y value was 1. Multiply that by 2, that's 2. So the next time we go over, now I'm up to y is 2. Multiply that by 2 again, now we're up to 4. If we went over again, we'd be up to 8, and then 16, and then 32, etc. And when you go backwards, you're doing the opposite. So if I go to the left, it's going to be half as much again, half as much, and decrease and decrease. So there's my curve for y equals 2 to the exponent x. For this second one, this time the growth factor is 5, but a is 2, so our y-intercept is 2. So I can plot that. Now my growth factor is 5. That means the next time I go over, my point is going to be 5 times as much. So here, y is 2. 5 times that would be 10. So I'm way off the chart already. If I go to the left, I'm going to be 1/5 of what I was. Somewhere down here. And 1/5 of that would be down here, etc. Gets smaller and smaller and smaller. So there's my curve for y equals 2 times 5 to the x. Our last one here, the growth factor is 10, but my y-intercept is 0.5. So my y-intercept is 0.5 right here. My growth factor is 10, so 10 times 0.5 would be 5. So when I go over, I'm up to 5 now. When I go backwards, I'm going to be 1/10 of what I was, so really small already. It'll get smaller and smaller and smaller and smaller. So there's my graph for y equals 0.5 times 10 to the x. And again, these are all exponential growth curves. But the main idea here is that if you know what your y-intercept is and your growth factor, you can plot the graph. So now we can use the same method to sketch these exponential relations. This time, b is less than 1 for each of them. So these are all going to be decay. For the first one, the decay factor is 0.9. A is 1. So the y-intercept is 1. Now the decay factor is 0.9. So every time we move over, it's going to be the y value times 0.9. So 1 times 0.9 is 0.9. 0.9 times 0.9 is 0.81. So you can see this is going to decrease smaller and smaller and smaller and smaller. Going the other way, we'll do the opposite. So when we go to the left, I'm going to divide by 0.9. So 1 divided by 0.9 is 1.11111. And so do that again, it's going to go up just a little bit more. So this is kind of a flatter curve, but it's still an exponential curve. For the next one, A is 2, B is 0.5. So if A is 2, the y-intercept is 2. The decay factor is 0.5. So we're multiplying our y values by 0.5 every time. Now the way you can think of it is it's always 50% of what it was in the previous spot. So we end up with a curve like this. In our last one, A is 0.5 and B is 0.1. So our y-intercept is 0.5. Our decay factor is 0.1. So we're multiplying our y values by 0.1 every time we go to the right. And every time we go to the left, we divide by 0.1. So our curve ends up looking like this. So regardless of whether you have exponential growth or exponential decay, you can make a graph as long as you know the y-intercept and the growth or decay factor.